Hello, welcome to our unique learning system math lesson. My name is Charlotte Lucas. I am an autism low incidence mentor teacher with Richmond Public Schools, and I am delighted to be able to work with you today. Our math lesson today is writing and simplifying expressions. We will start by examining a graphic organizer for algebraic expressions. Then we will discuss our vocabulary words. And finally, we will use word problems to simplify and solve addition and subtraction algebraic expressions. We have a lot to do, so let's get to work. What we want to start with is our graphic organizer. And our graphic organizer is designed to help us simplify the addition expression. We have our variables, and we have a way in which to separate and organize information. And finally, at the end, to solve. We've created the expression, and then we will solve it. So we will be using this graphic organizer. I would also like to go over some vocabulary with you. And that's this, when we go over this vocabulary, it will help you to understand what Ms. Lucas is talking about when we're talking about expressions and when we're talking about equations. So what is an expression? And we're in math now, so we're talking about a math expression. An expression is a sentence with a minimum of two numbers and at least one math operation. The math operation can be addition, subtraction, multiplication, and addition. The structure is this. The expression is a number, a math operator, and a number. So the expression has to have a number. It needs to have a math operator, addition, subtraction, multiplication, or division, and another number. The math operator and another number. That would make it an expression. Here's another example. We have a number. We have our math operator, and we have another number. Number, math operator, another number. That is an expression. All right, so the next question then would be, what is an equation? How do we compare the two? How do we differentiate the two? Okay, a math expression is different from a math equation. An equation will always use an equivalent operator, the equal sign, between two math expressions. So first you have to start with two math expressions. So an expression is a number, an operator, and a number. So that's a math expression. And another math expression, a number, an operator, and a number. There's another math expression. And what is in between it? The equivalent operator, the equal sign. Expression with an equal sign. That is an equation. Okay, let's do it again. Here we have an expression, number, operator, number. That's the expression. We have another expression, number, operator, number. And, excuse me, and in between the two is your equivalent operator. Now, an equivalent operator, this is the part that must be very clear. The equivalent operator means that this expression on this side has to have the same answer as the expression on this side. When it's equal, they have to be the same. So we have to make sure that this expression and this expression, when you do the math, will be the same. So let's check it out to make sure that it is equivalent. It's an equation. It has to be equivalent. So 25 plus 7. Let's use our calculator. as our strategy for today. And this calculator already has a number in it. So we need to clear it out. So let's clear. I always hit that extra clear button just to be safe. And 25 plus 7, we punch in 2, 5. Our operation is addition plus 7 and hit the equal 32. So 25 plus 7 is 32. Let's see if it is equivalent. We hit our clear button. 64 divided by, the operation is division, so let's find division, 2. What are we going to do now? Hit the equal button. Excellent. 32. So 32 equals 32. The equivalent, the equation is correct. Let's try this one. 20 times 5. First, we must, to use our calculator, first we must what? Clear. I hit that extra clear button. 20 multiply. We're going to use multiplication times 5. What are we going to hit now? That's right, the equal button. 100. Okay, we need to see if this equation, this expression 20 times 5 is equal to this expression 80 plus 20. So 20 times 5 is 100. Let's see if 80 plus 20 is 100. So 80, and we hit our plus button. The operation is addition, 20, and then we hit our equal button. Very good, 100. So if you have an equal sign, the expressions on each side must have the same answer. Whatever the expression is, it must have the same answer. So now we have examined what's the difference between an expression and an equation. An expression is two numbers with an operation in the middle. An expression, an equation is two expressions together with an equivalent operator in the middle. Whew, that's a lot of definitions this morning. Let's get back to our graphic organizer. So now we know that we have an algebraic. We're going to create the expression using variables. Our variables are A and B. A variable is the unknown. We don't know what the numbers are yet. So let's get a word problem and create our expression. This is our word problem. And with the word problem, we'll be able to replace the variable with a number. We will replace the variable with a number. All right. Mary Beth and Danielle are counting rubber ducks for Midway Field Day. Okay. A, Mary Beth counts 5 rubber ducks. B, Danielle counts B rubber ducks. Write an expression for the number of rubber ducks they count all together. Now we know that if we're using the word all together, we know that the operation is going to be addition. That's correct. We know that the operation is going to be addition because the word that is being used in the word problem is all together. All right, so let's see how that works. If we want to replace this variable with what A represents 5 that Mary Beth counts. So let's put 5 in. All right, and of course we have to put in our operation, which is addition. And now we have to figure out what is B. What number do we have for B? For B, Danielle counts B ducks. We don't have a number for B yet. B is unknown. So let's put our unknown in there. Five plus B. We don't know what B is yet. So we leave that variable in. All right, let's simplify it. Danielle counts. Now we find that Danielle counts 18 rubber ducks. See, Danielle was B. Danielle counts B ducks. We didn't know what B was yet, but now we know Danielle counts 18 rubber ducks. So let's put that in. We know that the A is what? 5. We knew that from the beginning. And now we have to bring over our addition sign. And now we know that B is 18. 5 plus 18. And now we're able to write our answer. Let's use our calculator. That's my strategy for today, is to use the calculator to get the answers. So first we use our calculator. We need to clear it out. So I'm going to hit the clear button, both of them. And I'm going to add 5, add plus 18. And we hit the equal sign to get the answer. And the answer is 23. Excellent. We did an algebraic expression. The expression is 5 plus 18, and the answer is 23. And we used our graphic organizer to keep us on track. Well, let's do another one. That is the same expression. Let's do another one. Let's do something different. We're going to simplify an expression using this word problem. Excuse me. And our variables are A and B. A. Maribeth inflates A balls. That means the number of balls that she inflated. We don't know what it is. It's A. We don't know. It's the variable A. That's the unknown. B. Danielle inflates 11 balls. We know what B is. B is 11. Write an expression for the number of balls they inflate together. They inflate all together. So we know our operation is addition. Excellent, excellent. You're with me. All right. So what is A? We don't know what A is yet. So we have to put the unknown, which is A. We have to bring over our operation, which is addition. And what is B? Right here, we find that B, Danielle inflates 11 balls. So we're able to put 11, A plus 11. That is the expression, but we don't know what A is yet. Let's find out what is A. What is Mary? How many balls did Mary Beth inflate? Let's find out what that is. All right, Mary Beth inflates 8 balls. How many balls do they inflate all together? Well, now we know what A is. Mary Beth is A. She inflates 8 balls. Let's put 8 and use our operation, which is addition. And we knew what B was. B is 11. We have written our expression, 8 plus 11. That is the expression. We found out what the variables were. We filled it in. And now we are able to get our answer. Let's use the calculator. The calculator has a number in, so let's get rid of that. Let's clear the calculator. And we will add 8 plus 11. So let's do that. 8, use the plus 11. Thank you. Hit equal. Excellent. The answer is 19. Let's put in the answer and we're done. Excellent. Algebraic expressions are not so hard now, are they? It's looking pretty easy and I like it. We have our expression. We started with A plus B. We found out what A was. We put that number in. We found out what B was. We put that number in, and then we solved the expression. Very good. You want to do one more? Let's do one more before we leave. All right. Well, let's do subtraction this time. This time we want our operation to be subtraction. And how will we know in a word problem if the operation subtraction is going to be used? Well, if you hear the words, how many are left, how many more than, or how many less than, you know you're going to be using the operation of subtraction. When you hear those words in a word problem, you know you're going to be using subtraction. How many are left? How many more than, or how many less than? All right. So this is a graphic organizer, again, it shows us we're using our variables A and B, and the operation that we're going to be using if we hear these words, how many are left, how many more than, and how many less, will be subtraction. After we simplify the expression by using the word problem to fill in the numbers with the given number, we replace the A and the B with the given numbers, and then we use those numbers to solve. That's what our graphic organizer is helping us to organize. Let's see. Let's read the problem and see if we're able to solve the subtraction expressions. Okay. Randy is collecting pool noodles that have been donated for Midway Field Day. You know what a pool noodle is, don't you? You rest on it and you're able to float in the water. That's really, really fabulous. Okay. So pool noodles. So Randy has collected 19 pool noodles. Randy is A. He has collected 19 pool noodles. So we know what A is. Okay. B, Randy has collected 19 pool noodles. For B, he has collected pool noodles so far. So he has collected 19. He has collected B noodles so far. Write an expression for the number of pool noodles he has left to collect. How many does he have left to collect? So we know the operation is going to be subtraction. Randy is collecting pool noodles that have been donated for Midway Field Day. Randy has collected 19 pool noodles. He has collected B noodles so far. Write an expression for the number of noodles he has left to collect. So the expression A, we know what A is. A is 19. We're just replacing A with 19 because we know what that is, but we don't know what B is. Okay, we know that we're going to be using the operation of subtraction, so let's put, but we don't know what B is yet, so we have to put the variable B in there because we don't know what it is yet. So our expression right now is 19 minus B. Let's see if we can figure out what B is. All right, Randy has collected 15 noodles so far. How many pool noodles does he have left to collect? So we know that 19 is A, and we know that we're going to be using the operation of subtraction. So for B, which we didn't know at first, now we know Randy has collected 15 pool noodles so far. Let's put that in. He's collected 15 noodles so far. So now we must simplify the expression to find out how many pool noodles does he have left to collect. So let's use our calculator. It has a number in it. Let's clear that out. We hit the C for clear, and then that one I hit it extra, that extra clear button. So 19 subtract 15. We have 19. This time our operation is subtraction, so we hit the subtraction, and we're going to subtract 15. Okay, to find the answer, we're going to hit equal. The answer is 4. We wrote our algebraic expression A minus B. We replaced A, the variable A, with the number that we found out that it was, which is 19. We replaced the alphabet B for the number 15 when we found out in the word problem what B was. And then we solved. 19 minus 15 equals 4. A minus B, 19 minus 15, and the answer is 4. Very good. Oh my, you're very good at this. Let's try another one. And then I think we can consider ourselves as having done a great job for today. So we'll be using the subtraction expression to solve this problem, filling out this graphic organizer. Ryan is giving out hula hoops to use for midday field day. A, Ryan must give out A hula hoops. We don't know what A is. A is the variable and A is the unknown, okay? B, he has given out 20 hula hoops so far. We know what B is. B is 20. Write an expression for the number of hula hoops he has left to give out. All right, so now we're ready to write the expression. A, what is A? We don't know. A is the unknown right now. So we must put in here that A, for our first expression, A, we know that our operation is subtraction because we have write an expression for the number of hula hoops he has left. That means the operation is subtraction. And B, do we know what B is? Yeah, B is 20. Right here, B, he has given out 20 hula hoops so far. So we're going to put for B, we're going to replace B with 20 because we know what B is. All right. Now we have to figure out what is A. Did they give us what A is? Let's find out. All right. Ryan must give out 32 hula hoops. How many hula hoops does he have left to give out? We just figured out what A is. A is 32. So we're able to replace A with the number 32. We know that our expression, our operation is going to be subtraction. So let's bring that down. That doesn't change. Subtraction. And B was always 20. We knew what B was. That was not unknown. We were given B. So now we have B, which is 20. Ooh, 29. That's not what it was. It was what? 20. Very good. You have to do it right. Check your work. All right. So our expression started with A minus B. We use the operation subtraction because it says, how many does he have left? That means that we must subtract. So at first we didn't have A. We didn't know what it was. So we used A minus 20. Then we were given how many hula hoops, which was 32, and we replaced A with 32. And we used the B, which we always knew was 20. So 32 minus 20. And now all we have to do is solve the expression. All right, let's use a calculator. May as well, because guess what? These numbers are larger. Can't do it in our head, and that's okay. So let's clear our calculator and start with 32 minus 20. Starting with 32, let's key in 32. 32, and our operation is subtraction, and 20. How are we going to get the answer? That's right, hit the equal button, 12. Our answer is 12. The difference between 32 and 20 is 12. Let's see if we can get that in there. Excellent. We were able to use the word problem, create our expression. Ryan must give out A hula hoops. We used A. He has given out 20 hula hoops. That was B. How many does he have left to give out? We didn't know what A was. So we read on and found that Ryan had given out 32 hula hoops. So we replaced A, the variable A, with 32 that we were given, and we subtract 20, which we already knew. Our expression became 32 minus 20, and we found the answer. The answer was 12. I'm telling you, we've done a lot today. We have used expressions, and we have solved the expressions. The expression for this was the operation was a subtraction, but we also used addition to solve an expression. So we've done a lot today, and you've done a great job. I hope that you'll look in for on tomorrow. We will also be doing algebraic expressions. I look forward to working with you. Have a great rest of your day. Bye-bye now.